Good morning, student. My name is Rekha Sadhu and I am your math science teacher. I have tried my best to teach you through my channel. I have solved the questions keeping in mind the state board examination. So dear student, watch the video, try to understand it, and even if you have any query or any doubt, you can ask me in comment box or personally. So let's start our first chapter, that is the real number. Good morning, student. Today we are starting the new chapter, that is real numbers. Now, in this chapter, the first topic is Euclid's division lemma. Now, according to Euclid's division lemma, for every positive integers a and b, there exist unique integers q and r satisfying a is equal to bq plus r, where r is greater equal to 0 and less than b. Let us try to understand this. Let us take two numbers, 16 and 3. Let a be 16 and b be 3. So here 16 is greater than 3. Now, if I divide this 16 by 3, I will get 3 5s are 15. So 1 is the remainder and it is represented by R. 5 is called the quotient and it is represented by Q. Now this 3 is B and it is called divisor. This 16 is A and it is called dividend. So divisor, dividend, quotient and remainder. Let us establish the relation between all these numbers. We can write 16 like this. 16 is equal to 3 into 5 plus 1. 3 5s are 15. 15 plus 1 is 16. So let's establish the relation between A, B, Q and R. We can write like this. A is equal to BQ plus R, where R is the remainder, Q is the quotient, and A and B are two numbers where A is greater than B. Now here the conditions for R. The R will be always greater equal to 0 and smaller than B. What it means? Now suppose I had taken 16 and it is divided by 3. If I take 17 and if I divide it by B, what answer I will get? 5 3s are 15, the remainder will be 2. Okay, suppose I take 18. If it is divided by 3, what answer I will get? 3 6 are 18. The remainder is 0. That means if my divisor is 3, the possibilities of remainder is either 0, 1, 2, but it never be 3. So we say that this remainder depends on divisor. It will be always smaller than divisor. Here divisor is 3. So my possibilities of remainder is 0, 1, 2. So I think this is clear. So this is Euclid's division lemma. Now next topic is Euclid's division algorithm. It is based on Euclid's division lemma. With the help of this, we can find the HCF of two numbers. So let us take the question from our exercise 1.1. The first question is, use Euclid's division algorithm to find the HCF of 135 and 225. So let us take the first question. The first is 135 and 225. Here 225 is greater than 135. So this will be the dividend and this will be the divisor. So I will write like this. Now I will divide 225 by 135. 135. So I will get 0, 9. Now here 90 is the remainder and 135 is the divisor. Now in next step, this 90 will become the divisor and 135 will become the dividend like this. So I will write 135 like this. See again, in the first division, 2 to 5 was the dividend. In second step, the divisor becomes the dividend and the remainder becomes the divisor. Now, I will divide 135 by 90. So, I will get 45. Now, again, 45 is the remainder. It will become divisor. Now, who will be the dividend? 90. So 90 will be the dividend and 45, which was remainder, will become the divisor. Now 45 2s are 90. I am getting the remainder 0. I will keep doing this until I don't get 0 as a remainder. So when you are getting 0 as a remainder, the divisor which gives 0 remainder is my HCF. When in exam, if they are asking what find HCF, you can solve like this and write HCF equals to 45. But when they are saying use Euclid's division algorithm, then you have to write few more steps. So how you will write? According to Euclid's algorithm, we know that ABQ plus R, A equal to BQ plus R, where R is greater equal to 0 and less than B. Okay, now see in the first division. Here, what is A? 2 to 5. What is B? 135. What is my quotient? Into 1. Plus, what is my remainder in that first case? 90. So, this is the first step. Now, see the second division. For the second division, dividend is 135. What is my divisor? 90. Into what is my quotient? 1. Plus what was the remainder that time? 45. Again I had done for the third time. So 90 is equal to 45 into what is the quotient here? 2 plus remainder is 0. So that remainder which is above 0 is my HCF. So I will write like this: HCF is equal to 45. So if they are saying use Euclid's division algorithm, we will write this much steps. Next question. 196 and 38220. In this case, 38220 is greater number and 196 is smaller number. So this will be dividend and this will be the divisor. Okay, so let's start dividing it. Now 196, I will take first three terms. So 196 ones are 196. So what I will get? 1. I will subtract 196 from 382. So I will get 681. Okay. Now what some students will do, they will take this as a remainder and will continue. Still 2 and 0 are left. So our division of first step is still not over. I will take out this 2 here. So don't make this mistake. This is not 186 is not my remainder. Still 2 and 0 is there. So I have to take them down first. Now 196 into 9, I will get 1764. Now I will subtract it from 1862. So I will get 98. I will take this 0 down now. This 0 is taken down, so it becomes 980. So 196 into 5 will give 980. So the remainder is 0. No need to take this again. Our division stops here. Now, in that case, we don't get any other divisor except this. So which is the last divisor for 0 as a remainder? 196. So 196 is my HCF. So HCF is equal to 196. Okay, now let's write according to Euclid's algorithm method. So A equal to BQ plus R, where R is greater equal to 0 and smaller than B. Okay, here what is my A? 38220. What is my B? 196 into 195. What is my remainder? 0. So if you are getting the 0 in the first division only, then the divisor is the HCF of that two number. Question number 2. Show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some integer. So let us show that. According to Euclid's algorithm, what we have? A equal to BQ plus R, where R is greater than equal to 0, less than B. Now here, my B is 6. So, let us take B equal to 6. If B is 6, then it will become A is equal to 6Q plus R.
Start.
A equal to 6Q plus R. Now, if B is 6, so what are the possibilities for R? R will be 0, 1, 2, 3, 4, 5. But it not be more than 5 because my divisor is 6. Okay. If R is equal to 0. If I put the value of R in this, what I will get? A equal to 6Q plus 0. That is A equal to 6Q. Okay, if I put R equals to 1, then I will get 6Q plus 1. Now see here, this 6Q can be written as 2 into 3Q. So this is the multiple of 2. So multiple of 2 is always a even number. So this is even positive number. Now here 6Q plus 1. So this is odd number because 6Q is even. Even plus 1 will be odd positive integer. You can write integer here. Okay, now if I put R equal to 2, I will get A equal to 6Q plus 2. I can take 2 common. So this becomes 3Q plus 1. Again, this is the multiple of 2. So this is also even positive integer. If I take R equal to 3, A equal to 6Q plus 3 because R is 3. So again this is odd. Why? Because 6Q is even. Even plus 3 will be odd positive integer. If R is equal to 4, the same thing, A equal to 6Q plus 4. I can take 2 common, 3Q plus 2. So again this is even positive integer. Now the last, if I take R is equal to 5. So I will get A is equal to 6Q plus 5. Now this is even number. 6Q is even. Even plus 5 will give me the odd positive integer. So here 6Q plus 1 is odd. 6Q plus 3 is odd. 6Q plus 5 is odd. And that thing we have to prove that it will be either 6Q plus 1, 6Q plus 3 or 6Q plus 5. Therefore, we say that any positive odd integer is of the form 6Q plus 1 or 6Q plus 3 or 6Q plus 5 where Q is some integer. Question 3. In this question, there are 616 army members and they have to march behind 32 members of army band. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? Here, maximum number of columns. Maximum means highest. So, highest common factor, that is HCF. I will find the HCF of 616 and 32. 616 is greater than 32. So this will be the dividend, this will be the divisor. So I will write like this, 32 is a divisor. When I will divide 616 by 32, I will get the remainder 8. Again, 8 will become the divisor, 32 will become the dividend. So 8 fours are 32. I am getting the remainder 0. So my HCF is 8. So the answer is 8 columns. Now here no need to write that Euclid steps because here we have to find only HCF. Question 4. Use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integers m. So according to Euclid's algorithm lemma, division lemma, what we have? A equal to BQ plus R, where R is greater than equal to 0 and smaller than B. Now here 3m plus 1. So let B equal to 3. So I will get A equal to 3Q plus R. If my divisor is 3, then what are the possibilities for R? It may be 0, 1 or 2. But it never be greater than 2 because divisor is 3. Okay. If R is 0, then A equal to 3Q plus 0. So A equal to 3Q. Now here in the question, they had said that square of any positive integer. So I will do the square of it. So A square will become 3Q whole square. So this becomes 9Q square. Okay. This can be written as 3Q square. Now here Q is any integer. So this whole number will be some integer. So let us take it as M. So I can say that A square is equal to 3M. Okay. If R is equal to 1. So here it will become A equal to 3Q plus 1. I am putting this. Okay. So squaring on both the sides, I will get. So you are knowing the formula of A plus B whole square. A plus B whole square is A square plus 2AB plus B square. So A square, that means 3Q square plus 2AB. So 2 into 3Q plus into 1. So 2AB. Plus B square, my B is 1. So 1 square. It becomes 9Q square plus 6Q plus 1. 3 2s are 6Q. Okay. Now here, from this 2, I can take 3 common. So it will become 3Q square plus 2Q. I can take Q also common. But Q is not needed. I want to prove 3M plus 1. So I will always take 3 as common. Whenever I have to prove that the number is an even number, I will always take 2 outside, which shows that the number is even. But here we need 3m and 3m plus 1. So what we will do? I will always take out 3 only. Okay, so plus 1. Now here also Q is some integer, so this whole number will be some integer, so it will be taken as M. So it becomes 3M. This whole is taken as M plus 1. Okay. Next, if I take R equal to 2, again A equal to 3Q plus 2. If I do the squaring, it becomes 3Q plus 2 whole square. So this becomes 3Q square plus 2 into 3q into 2 plus 2 square. A square plus 2ab plus b square. Now 3 square means 9q square plus 2 3s are 6, 6 2s are 12. 12q plus 4. Now it is not possible to take 3 common from all the 3. So what I will do, I will write like this. If I take this common, there will be 4. So I will write like this, 9q square plus 12q plus 3 plus 1. This 4 is written as 3 plus 1. So now I am able to take 3 common outside. So this becomes 3q square plus 4q plus 1. From this I had taken common 3. This one as it is. So this becomes, now here q is an integer. For any value of q, I will get this number also an integer. So it will be placed like m. So from this, I conclude that if r is 0, I am getting 3m. If r is 1, I am getting 3m plus 1. If r is 2, I am getting 3m plus 1. That only we have to prove. We have to prove this, that the square of any positive number integer is either of the form this or this. So it will be either 3m or 3m plus 1. Question 5. This question 5 is same like question number 4. But in this case there was a square. Here we have q. So it will be done by the same method, but instead of taking a square, we have to take a cube, and here also cube. So this question you will do by yourself. The same method is there. There will be r equal to 0, r equal to 1, r equal to 2. But instead of doing square, you will do cube, and you will use the formula of a plus b whole cube. For r equal to 1 and r equal to 2, instead of taking square, you will take cube, and you will use this. You will get the solution. You will get 9m plus 1 or 9m plus 8. Thank you.